Onward to number 8, and I'll do 7 here. This is where it gets a little dicey sometimes, is trying to figure out how to state your null and your alternate hypothesis, and I'll give you my how I generally do it, and hopefully that's helpful then to everybody. So give it a go. We'll read the problem here. 7 says a recent national survey found that high school students watched an average mean of 6.8 DVDs per month. So that's going to be the mean of our population, basically, with population standard deviation of 1.8. So we put that in there. The distribution of DVDs watched per month follows the normal distribution. A random sample of 36 college students, so we're flipping from high school to college, but that's all right, revealed that the mean number of DVDs watched last month was 6.2, right? Okay, so n is my 36 is my n, sorry. N is 36, and the mu, or my sample mean, is 6.2. At the 0.05 significance, boom, level, can we conclude that college students watch fewer DVDs a month than high school students? Well, first thing, okay, put your information. These story problems get to be kind of complex sometimes, so make sure you just label your information, kind of like I've done here. And if you do this once, then you can copy it over, because you do it on most of these equations back here. Okay, then we have to establish our hypothesis, right? Let's do that first, and we'll talk about some of the other stuff. So I'm going to tell you this. I tend to start with the alternate hypothesis. For whatever reason, generally speaking, the question is, and I'll read it again, at the 0.05 significance level, can we conclude that college students watch fewer DVDs a month than high school students? So I'm going to say that my alternate hypothesis then is that H sub O, or it should be H sub 1, I'm sorry. Okay, and again, I kind of showed you how to do that, so we'll H, sub 1 is that mu is less than 6.8, and H sub 0 is that mu is greater than or equal to. I wonder if I could find that really quick. We'll take a look. Symbol. I got a basic Latin I want. Oh, except I got it right here. Okay. Insert. Close. Cool. Greater than or equal to 6.8. Why it does that, I don't know. It's really weird why it does that. So we got to do that, and I got to put that back to 11. No idea. It's just such a goofy thing. Okay. So there we go. So I've stated my hypotheses there, right? Okay. And again, I look at it. I do the alternate hypothesis kind of based on the question that they've asked. Then we just have to do our work, right? We find a z value. Oh, we got to say b though, right? Because for all of these we have to do b, which is what is the decision rule. We got a one-tailed test, and I hope I've gone through the one-tailed test before. But our significance is 0.05, and we're less than. And so since we're less than, it's going to be, if it's less than, okay, minus 1.65. Well, how do we find that? Okay, we down here to the chart first, but that's 0.45, right? So I got 0.4495, 0.45, so it's 1.645. So probably 1.65. We'll use that, right? The other way to look at that would be to say, we're going to come down here. 45% is what I'm looking for. If I look at the percent, yeah, that's about as close as I get, right? Shoot, I thought I hit that. There it is. Okay, so minus 1.65 is my number. okay, is reject if z is less than minus 1.65. So then we just do our math, and we've done the math before, right? So I've got my mu is 6.2 minus that is minus 6.6. That's the top. My square root of n is going to be 6, and my standard deviation is 1.8, so I got 1.8 divided by 6 is 0.3, and so my answer then, of course, is equal to minus 0.6 divided by 0.3, or minus 2. Well, is minus 2 less than minus 1.65? Yes, it is. Okay, minus 2 is, okay, so then we reject it in this case because it is outside of that. So we reject our hypothesis that it's equal to or greater than. Okay, so we reject the null hypothesis. Okay, and so then we look up our minus 2, and we can do that here. Boom. 47.72, or of course we could do that down below, 2 in the chart down there. Okay, 47.72, but we take, again, what we're interested in is this part of it. Okay, and so we could do it this way too. You know, we could say from here, oops, up to boom, 2.28%. That's what I have here. I don't have it expressed as a percent, but I sure could. So it supports the conclusion. It says only about one time in 40 would you get an answer like this if h sub 0 is true. Okay, so we're rejecting this. Okay, only about one time in 40 would we get an answer above 6.8, right? Okay, hope that makes sense to everybody.